everyone. Today we'll discuss about introduction about theory of computation. Okay, so we simply call it as TOC. TOC is a fundamental course of computer science. Whoever is taking computer science engineering as a major course in the engineering background, they should learn about theory of computation. Okay, so how people thought about this computer science as a science for past 50 years, how people were thought. So those things will be covering in this theory of computation. So what can be computed, what are all the things can be computed by mechanically, what are all the things can be computed. So and when it is possible to compute something, when it is possible to compute for solution for some problems, how much time, how fast, that is how much time it takes to solve the problem, and you have to consider about the space occupies to solve that particular problem. So two things were there. The one is time complexity, second one is space complexity. The first one is how fast the machine works for a given set of problems and how much space it occupies to get the solution for that particular problem. These are all the two major things we have to note it down. So in theory of computation, for example, when people were thought about the computer, whether this computer will solve our problem or not, that was the question. So that times we were asking simple questions to the machines. So we want to design design a machine that will accept all binary strings that ends in 0 and reject all other strings that does not ends in 0. This is the problem. Okay, just take it as an example. So you have to design a machine which accepts all binary strings that ends in 0, and it should reject for the strings whichever does not ends with 0. So for example, when you take the string, take the strings, how will you design a machine for this particular problem? So this is the input you are giving to the particular machine. How the machine will react for this particular input. So you are giving this input, it should read the last digit of the given binary string, and it should say, by scanning this last digit, it should say whether this input will be accepted or not. So it scans the last digit. If it is 0, it will say yes and it accepts the input. If it is not 0, which means it either, in binary strings only we have two options. The strings will contain zeros or ones, right? So when the machine sees 0, scans 0, it will say the string is accepted. When it is not 0, it is obviously 1. So which means it should reject the strings whichever we have given. So these strings will be accepted that in such a way that you have to design the machine. So in that particular, when you are designing a machine, the main task of the machine is that the machine will scan the last digit of the given input, and it will say whether the input is accepted or not. Okay, this is the first kind of problem that can be solvable by the machine. Second problem you just see. So you have to design a machine which will accept all valid Java codes. Okay, this is the problem statement. So you are designing some machine, that machine should accept all valid Java code. How will you verify, how will you confirm that the given input is the Java code or not? So this is very see, nowadays we are using these things. If you people think about what is the machine we have created for this problem, just think it. So the thing is that the machine should scan for the input whichever we have given, and it should match the whatever input we have given. The input should be converted into binary codes, and that codes will be verified with the valid piece of Java code, and it will say whether the given input is Java code or not. So in such kind of situation, what is the task of the machine? It will have some it should know the syntax of the Java code. So we have the format for Java, C++, those kind of programming languages. We have the format, we have the syntax, right? So the machine should know about the Java code and valid Java code, how the valid Java code looks like. So that things that thing should be known by the computer or machine. And when you are giving the input to the machine, it should convert that input to the binary code, and then it will check for the confirmation whether the code is the valid piece of comes from the valid piece of Java code or not. If it is valid piece, and it will say, it will accept the string whichever given. If it is not, then it will reject the code whichever given, or it will throw the error for that given input. So for a very live example for this Java code, this second example is that compiler is the software which we have created to check the given input is whether valid Java or not. So what the compiler will do, it will compile. The compiler is a software which will convert the given high level language program into the machine understandable format. So in that case, when you are writing a Java code, and if you are feeding to the machine called compiler, the compiler will check for the validity, and whether if it is valid Java, and it will accept, and it will execute the, and we can run the code. If it is not, if there is an error, what will happen? The compiler will throw the error, and it will reject the whatever code we have written. It will reject the code. Okay, that is what the problem. So when we have two problems, okay, these two problems can be solvable by the machine, right? So we are seeing whether what are all the things that can be computed by the computable by the machine. So these problems are example for the computability. These problems can be computable by the machine. Okay, and now we'll see what are all the problems that cannot be solvable by the machine. Simple example for that. So you just take the same example, second example whichever we given. So you have to design a machine that should accept all valid Java codes. Okay, with that I'm just adding one more statement. The machine should accept all valid Java codes, and you have to confirm that the given string is the string does not go to infinite loop. Okay, so whether it is possible to machine design a machine for accepting all Java codes, and it does not go, you have to prove that the machine should prove that the given input does not go to infinite loop. Okay, this is the problem statement, whether you can able to design a machine or not. Just think for a while, and we'll see for the answer soon.